Hello guys, in this video we look into this question number 2.2. Diagram 8.1 shows a tanker of mass 40,000 kg move with a velocity 20 meter in 1 second. So the first one state whether velocity is a scalar quantity or vector quantity. So here you need to remember that we have two types of quantity, physical quantity in physics. So the first one is what we call as scalar quantity, and the second one is vector quantity. So what is the difference between these two quantities? Okay, scalar quantity normally it has the magnitude only. Okay, it has magnitude only. But for vector quantity, it has the magnitude plus the direction. So that is the difference between scalar quantity and vector quantity. So for velocity, velocity is one of the vector quantity. So we should answer here vector quantity. Other quantities which is can be categorized as vector quantity will have acceleration, and then we have force, momentum, and others lah. Speed, which has the same unit with the velocity, and it has same formula with the velocity, but it is categorized as scalar quantity. Okay, next. After 2.5 seconds, the brake is applied. The tanker stops. Calculate the deceleration of the tanker. So in this question, they ask us to find the deceleration of the tanker. So in this kind of question, first take out the information that you have. So the first one we have 40,000 kilogram, and then velocity. Okay, you may write this as velocity. V equals to 20 meter in 1 second. So in question B, after 2.5 seconds, the brake is applied. The tanker stops. So let's sketch first what happened to the tanker. So this is your tanker. It is moving at 20 meter in 1 second. And then after 2.5 seconds, it stopped. So now you can see that it has two different position. The first one, it is moving at 20 meter in 1 second. And then the second one is, okay, it is stop. So that means the velocity is equals to, the speed is equals to 0. So here you can take this one as your initial velocity, and then you can take this one as your final velocity. So the change of velocity occurs in the period of 2.5 seconds. So this is the time before the tanker stop. Okay, now how can we calculate the deceleration of the tanker? What are the informations that we have here is initial velocity, final velocity, and time. And then if you look into your formula, okay, you have U, you have V, and then you have T. And then you want, or you are being asked to find the value of A. So these are the variables that involved in your questions. So you want to find A. So try to get any formula that will include all of these variables. That means in the formula you have U, V, T, and A. So what is the formula? So the only formula that we can use is V equals to U minus AT. Or you can write it as A equals to V minus U divided by T. So based on the definition of the acceleration, acceleration is the rate, okay, divided by time, rate. V minus U is the change in velocity, rate of change of velocity. So by using this formula, you can find the value of deceleration. So A equals to V, which is 0, minus U, which is 20, divided by the time taken, which is 2.5 seconds. So you will get negative 8 meter per second square. So this is your value for the acceleration. Okay, since the question asks you to find the value of deceleration, so deceleration is equals to 8 meter per second square. Okay, if the question asks for acceleration, you can give negative 8 meter per second square. But since the question had already asked you to find the deceleration, so you can write it as 8 meter per second square. So in this question, you need to be careful, okay? The time is given 2.5. Initial velocity is given 20 meter in 1 second. Okay, the hidden information here is the tanker stops. So that's mean the final velocity is equals to 0. Okay, next question number 2. The distance traveled between the brake is applied and the tanker stop. So we have the first condition, and then after 2.5 seconds, the tanker stops. So here we have initial velocity equals to 20 meter in 1 second, and then final velocity is equals to 0 meter in 1 second. The time taken to stop is 2.5 second, and deceleration or the deceleration is minus 8 meter per second square. So here you can write the information that you have here. You have U, you have V, and then you have T, and then you have A, and then the one that being asked here is S. So look back at your formulas in state of motion. What is the formula that involve all of these variables that it can use in your formula? Okay, if we try to list down all of the formulas, so first one you have S equals to ut plus half et square. The second formula you have S equals to half u plus vt. And the last one you have v square equals to u square plus 2as. So if you look carefully into these three formulas, all of the formulas have all of these variables in it. So that means we can use either one of them. Okay, let's say you want to use the first one. So I will show you how can we use all three of them to find the answer for the question 2. Okay, let's try the first one. S equals to ut plus half at square. Let's substitute the value. U20, T 2.5, and then half A is minus 8. Okay, remember for A in your formula, please do not substitute with the value of deceleration, which is 8. Okay, you must use negative 8. And then the T square. Okay, this is T square is equals to 2.5 square. So you will get 25 meter. Okay, let's say you want to use the second formula. S equals to half U plus VT. So you can substitute the value. Half U 20, V is 0, and then T is 2.5. So you will get 220, 10, 25. So you will get 25 meter. Okay, same answer with the first one. What about the third one, which is V square equals to U square plus 2AS. Okay, let's try to substitute. V square is 0. U square, which is 20 square plus 2. A is 8 meter minus, negative 8 meter per second square. And then S, what is your S? Okay, you want to find the value for S. You will get 20 square minus 16S. So let's rearrange our equation. 16S equals to 20 square, 400. So S, you will get 25 meter. You can see here that by using either one of these three formulas, you can find the answer for question number 2. So that's all for this question. Thank you.